Let's look at one last example. Now for this example, let's start off with mood and figure. Let's reconstruct the logical form of the argument, and then let's use our Venn diagrams to evaluate whether the argument is valid or invalid in both logics. So remember, my mood here are the letter names for the categorical syllogisms in standard form. So the first letter is the major premise, the second letter is the minor premise, and the third letter is the conclusion. So type A here, that is a universal affirmative. So I say to myself, okay, that major premise then, its quantifier is going to be all, and its copula is going to be R. Like so. Now, I say, okay, that second premise, the minor premise, is the type E. Type E is a universal negative, so my quantifier is going to be no, and my copula is going to be R. Finally, this I here, that's the letter name for my conclusion. I know that the subject of my conclusion is the minor premise. I know that, minor term. I know that the predicate of the conclusion is the major term, and so I know I can put letters in for them. And this is a particular affirmative. So my quantifier is some. My subject term I'll use S for, that's my minor term letter. R, it's affirmative. And P. My predicate term is my major term, I'll use P for that. Now I know that P is going to go in that first premise, the major premise. I know that S, my minor term, is going to go in the second premise, the minor premise. I don't know where they go, subject or predicate, until I use that figure to figure out where the middle or bridging terms are. So my figure here is a figure 2. So the relationship for each of the figures, the figure 1 relationship, middle of bridging term is in the subject of the major, the predicate of the minor. It goes like that. Figure 2, it's in the predicate of the major, predicate of the minor. Figure 3, it's in the subject of the major, subject of the minor. And figure 4, it's in the predicate of the major and the subject of the minor. So a figure 2 here then is going to be where they're both in the predicate slot. So I put those M's in. Now I know that the predicate of the conclusion, the major term, goes in that first premise. The subject of the conclusion, the minor term, goes in that second premise. So now I've reconstructed the logical form of the argument from that mood and figure. Now I can use my Venn diagrams to evaluate the argument for validity or invalidity. Again, I'm going to put a premise diagram in with 3 circles. My minor term, in this case S, bottom left. My major term, the predicate of the conclusion, in this case P, bottom right. My middle of bridging term, in this case M, the one that's in both premises, always up top. Premise diagram, conclusion diagram, exactly the same. They're just labeled premise and conclusion. Gonna fill in my premise diagram with what I need to make both of my premises true, and my conclusion diagram with what I need to make my conclusion true. So again, both of these are universal statements, so it doesn't matter which one I use. Let's go ahead and start with that minor premise here. Again, I start off in Boolean logic. This says no S or M. I don't know if there are any M's, and I don't know if there are any S's. But what I do know is, if this premise is true, nothing that's in that S class is also in the M class. So this area here would have to be empty. So I shade that in, indicating it's got to be empty, and that's what gives me the truth conditions for that second premise, my minor premise. My major premise says all P or M. So again, don't know if there are any P's, I don't know if there are any M's, but what I do know is everything in this P circle is also in the M circle here. And so this area here and this area here in P outside of M, those would have to be empty if that first premise, the major premise, is true. So I'll shade those areas in. That's what absolutely has to be the case for both of my premises to be true. Now I go and I look at my conclusion. Sum S R P. Again, sum is the particular. There's at least one thing. It is an S and it is a P. So there's at least one thing. It's inside the S circle and it's inside the P circle. So it's got to be in this area here, this intersection where the circles overlap so that anything in there is both an S and a P. But again, this area has two parts to it now because that M bisects this intersection. This doesn't tell me what that X would have to be with regard to M. Is it an M? Is it not an M? It doesn't say. So I'll put my X inside this intersection and I'll put it on the line here so that I know that if it's an M and an S and a P, that would make it true. If it's an S and a P and not an M, that would also make it true. Either way will make that conclusion true. As long as I've got an X somewhere in this area, my conclusion is true, and my conclusion doesn't give me enough information to put it in one side or the other. So now I've got my conclusion. This is what I need for my conclusion to be guaranteed to be true. I look over here at my premise diagram. I look at that area. That area has to be empty. So if my premises are true, I'm not going to have anything in this intersection guaranteed, so that argument is invalid in Boolean. When it's invalid in Boolean, I always test it for Aristotelian. So don't have to worry about my conclusion diagram. I only have to worry about my premise diagram. I go through, I look at each circle, and I ask myself, does it have an X? That is, does it have a member? If it doesn't, is there one and only one of the four areas where it could go? If there's more than one, I don't add it. If there's just one, then I put the X in that one area and I circle it to remind myself I only know that because I'm Aristotelian in how I understand categories. So let's start with my M circle here. My M circle doesn't have any X's in it, but it has one, two areas where that X could go. So I can't put an X in because I don't know exactly where it would go. What about my P circle? Well, it can't go here, and it can't go here, and it can't go here, and it doesn't have an X. So I know that I'm going to put an X in here. The same thing with my S circle. Doesn't have an X, so I can't put it here, I can't put it here, I can't put it here. I know it'll go here. So I'll go ahead and fill in these two areas here with X's. I circle them to remind myself I'm only entitled to this because I'm being a good Aristotelian now, and because this is the only place where P could have a member. I'm being a good Aristotelian, and this is the only place where S could have a member. Now, this is how the world has to be in order for my premises to be true under the Aristotelian assumption. This is how the world's going to be, minimally. This is what I need to make my conclusion true. I need an X somewhere in here. I go over, I look, still can't get an X in that intersection, and so this argument is invalid in Aristotelian logic. All right, so those are three examples of doing syllogisms with our Venn diagram technique.